Okay. Yeah.
There you go. You can also edit it and you can cut out as well.
Yeah. Sure. Okay. So let's begin and let's start again here.
Yep.
Okay. So this is what I will cover. About Philatech, and then I'll cover about what is 3D printing. I'll cover about types of 3D printing and FDM as one technology of 3D printing, and I want to cover it in a bit detail. Yeah. And I also cover about the market size of 3D printing or across the globe, benefits of 3D printing, disadvantages of 3D printing, which is something we should know, where we should not use 3D printing. Sometimes what happens is, let's say what people do is they use 3D printing as a hammer. And when I have a hammer, everything seems like a nail. And I don't
I love that. I love that. Yeah, yeah. Everything looks like a nail. Yeah.
Yeah. So you should not use 3D printing for each and everything. It's a technology for manufacturing. It is not a holy grail of manufacturing which will solve all your problems.
Amazing.
And
Amazing.
because of
Amazing.
this mentality, what has happened is there is a hype which has been created around it, which kind of came as a bubble. And
Yeah.
when the bubble is overinflated, it kinds of breaks. So that's why I wanted to cover disadvantage of 3D printing and why you should not use 3D printing for certain applications. And how is 3D printing ecosystem getting developed in UAE, and what I feel that future of 3D printing will evolve. That's what I will cover in this session. Yeah.
Right.
Okay.
Sounds good.
So I will just play a small video about Philatech 3D printing. Just let me know if the sound is coming so that you know what we do as a factory. Yeah. Is the sound coming? Okay. How do I share
No, no. So what
sound?
you do is when you share,
Mm-hmm.
if you stop sharing,
Okay.
and then when you press share, let me just find it. You'll see under options it says share sound.
Pause
Can you
to
see that?
multiple.
So under as you press the share button, I'll take a photo. I'll send that to you.
But I'm sharing from a computer, so
Yeah. So hang on. Yeah, just had to find you. Yeah. So under options, when you press share
Mhm.
at the bottom, you come
Mhm.
up with some options. I've just WhatsApped the photo of it, and you just click on the button that says share sound.
Okay. Um, Unfortunately, I don't see anything. I say all participants can share. How do I do that? More.
Uh,
Okay. Let me see once again because in computer it used to come automatically, right?
Sometimes it does
Share sound.
set
I
up.
see that. I see that. Share sound. Yeah, I got it. I
That's
got
it.
it.
That's
Yeah,
it. That's
got
it.
it. Got it. Got it. Got it.
No problem. Right.
Hear the
Got
sound?
it. Feel like that's it. Right. And then if you get stuck,
So
Nice.
that was our factory where we produce the filaments, which is used as a starting point of 3D printing. That means we start in the entire supply chain of 3D printing. We are the starting. We produce the raw material. We supply to the end users who use the 3D printing machines to make objects, and they give it to the end users for their use. So that's what.
Got it. Got it.
So we are the raw material producer for 3D printing, and we use something called the product that we have is called filaments, FDM filaments. You will come to know later in the
Okay.
presentation, where it is being used and also. So we started our journey in 2016 as a company is established in Ras Al Khaimah, Al Hamra Free Zone Technology Free Park. And 2017 we started making 2000 October it started, and 2017 is when the factory started operating and start making the filaments. 2018 we started making with ordinary filaments and special filaments, which I'll come to that later. And then 2018 we launched two additional products called wood PLA and fila engineering. And fila engineering is some special materials which is used for end use engineering applications. Okay, and some of our engineering materials have very big demand in UK and in Europe. And in 2018, same we got a Best New Technology Award from Rakis. And 2019, we started our UK and UK sales operations. 2020, we started
Wow.
our Germany sales operations. And 2022, we have established a partnership, a dealership in Saudi Arabia. And 2024, we started expanding our portfolio by starting metal 3D printing and also adding couple of lines. So this is how the journey of Filatech started. And bottom, you see the products that we have. These are the products. This is the end product, how it looks like. It's like a spool. It is
Hmm.
wound like a fiber, a thick fiber. We make it in two different diameters, 1.75. And in one of the in the in the video you would have seen there is a measuring equipment which shows 1.75, and
Yep. Yep.
so these are different colors. This is the powder which we started to. We are in the process of making a factory in Germany, Berlin, for making this 3D printing metal powder. So that's the next expansion plan that we are having.
Amazing. Congratulations. What
Sure.
a great story.
Yeah.
Amazing.
Okay. So what is 3D printing? So that's what I want to touch upon now. So 3D printing is just making objects layer by layer. That is it. That means we add on top of it rather than subtracting. So let's say what you see on the left is adding layer by layer and making an object. And what you see on the right is the most commonly known manufacturing method, which is machining or subtracting, where you take a block of a material and then you carve out material to get the desired shapes, using CNC machines and all. So that is subtractive manufacturing, and what you call 3D printing is additive manufacturing or layer by layer manufacturing.
Gotcha.
For me, 3D printing is like progress. What I say to people is, let's say, long back, we used to make house out of stones. We carve
Yeah.
out,
Yeah.
we live inside.
Yeah. Yeah.
But
Yeah.
now we make in layers. Multi-storied building we make in layers. One layer at a time we are making. So that is why I always say when we move from subtractive to additive, we are into progressing. It's
Amazing.
like
That's really good. I
yeah.
like it. I like it.
Okay. Yeah, sure. So I'll come into it later, how it is done, etc. etc. For basics, it is so the 3D printing. Why it is called 3D printing is like an extension of 2D printing. 2D printing, what you do is you print on two dimensions, right? That's where you have a paper and you print on XY dimension.
Come here.
But if you add a third dimension, which is Z, on layer on top of each other, that is why it will become object. So that's why it is called 3D printing. Otherwise, the standard term is additive manufacturing. As an engineering term, what we call it is additive manufacturing.
Gotcha. Gotcha.
Okay. Yeah. So how is 3D printing done? This is a digital manufacturing method where it's an interface between digital and physical, as I say. You have something you design digitally in a computer, which is from a CAD or a 3D scan. That's what you call it as here. It is a It is a digital model which you have created. I'll show you examples of that. And then what we do is we slice it into multiple layers. So I've taken this model and sliced it into multiple layers. Okay. And I make one layer at a time by giving the slicing information as a tool path to my maker. So I give
Ah,
slicing
okay.
information
Yeah,
to the
no, it
tool
makes
path,
sense.
and then it goes like this and makes it, and that's how the object gets formed. I'll show you some videos of that
Ah,
also. So
ah,
that's what how 3D all 3D printing methods have this as the basis.
gotcha. Yeah,
Digital
it makes
CAD
sense.
input,
Thank you.
then slicing into multiple layers and layers. And the technology differentiation is how these two, three layers are formed and how they're, adhering to each other. That's the only difference which happens. And sometimes, material also is coming as different. So let me come to the next. So classification of technologies, one is based on material. So we have 3D printing in metal, we have 3D printing in polymer, ceramics, and concrete. And we can, other materials also. The broad class,
Concrete.
the
Sorry,
broad class.
concrete.
Yeah, concrete.
Whoa,
There are buildings in Dubai, villas and flats, which are made using concrete 3D printing over here.
good God.
Yeah.
Wow,
And
I didn't
when
know.
it comes to polymer, plastics can start with melting at 180 degrees Celsius. And when it comes to metal, the material melting temperature of these materials can go up to 3000 degrees Celsius.
Whoa.
Yeah, because titanium melts at 3000, close to 3000 degrees Celsius. So the amount of heat input is different, the amount of stresses generated is different. So each material has a different type of classification, out of which I will say polymer is the easiest. And in polymer also different classification is there. The normal polymer, the engineering polymer, the super polymer, all depending upon the temperature at which the material is being processed.
Interesting.
And then
It's
there are
interesting. Sorry, it's interesting when you say that metal melt, and it's like, oh yeah, I suppose it does. Yeah.
and then there is depending upon the type of raw material, like sometimes it is in powder form, sometimes it is in liquid form. Some polymers are in liquid form, there are polymers in liquid form, and then some the one which we do is in wire form, the one which we use, we make it the raw material in wire form. Some of them use in powder form, so technology changes based on how you feed it. Sometimes it is fed on a bed, sometimes it is feed using a nozzle. So many technologies, so many combinations are there. But for a basic understanding, this is what we should know. The material, then different depending on the technology. Technology is based like SLA, FDM, SLS, SLM, and all different types. How the material is fed is what classifies this. So what we will be doing today in detail is FDM. It's called fused deposition modeling. FDM is fused
Fused.
deposition modeling.
Whoa. Okay,
So
got it.
when it's a fused means the material is melting and fused. Okay. And deposition is it is between deposition and modeling means basically it is making. So that is why FDM as a technology. And many a times people don't even think FDM is an acronym. It's like FDM. Okay, FDM. Yeah.
Yeah, okay, yeah.
Like, so that's how it is there. Yeah. So now, when it comes to FDM, this is what FDM, which is the most popular 3D printing method in the world. It's the most. It's like everybody who starts 3D printing starts with this. Unfortunately, I
Yep.
did the reverse. I started with the metal 3D printing. I then went into polymer, which is again high temperature melting using powder. And then I came to FDM. So now I am back to basics.
Yeah, that's funny. I like that. I like that.
Yeah. So basically what it does is this spool you see on the top,
Yeah,
this is the raw material and this is what we make. Okay. Yeah. And this spool is a thermoplastic, which is like a line, a thread with a certain diameter. This is the raw material and it is fed through a nozzle. This is the nozzle. I'm not sure if it's very clear. I'll come to that. This is a nozzle.
sure.
And there is a there is a mechanism which will pull the thing down and push it, and there is a hot end which is called a nozzle, which is temperature controlled, and it will melt the filament, and it will deposit according to the layer, the you remember the layer which we told earlier,
Yeah, yeah,
layer,
yeah.
so it will go and deposit. So the fusing is happening and deposition is happening and the making is happening. So that is what fuse deposition modeling. So that's how
Perfect. Perfect. Thank you.
this thing gets made, and it is deposited layer by layer, layer by layer, layer by layer, and we get the final part. Trust me, this technology started around 1985, 1985.
Wow.
Yeah.
Wow.
And at
Wow.
that time, it was printing in snail pace, it was like going slowly and depositing. Now it is like super fast. In last 2 years, the speed at which was happening at 2 millimeter, 3 millimeter per seconds has now,
Woo.
in the last 2 years, 1984 to 2020, 23, the speed was very less. But 2023 to 2025, now the printing speed is 6,000 millimeter per second. It's like super fast.
What?
Yeah. 600 millimeter per second. It will go to 1,000 millimeter per seconds. Right now, in this year, is what the 2025. There is a new printer which is coming out. It will go to 1,000 millimeter per seconds. And I'll show you some
Wow.
videos, then you will understand, how
Yeah, yeah, yeah,
thing is
yeah.
getting printed. So I want to show you something which I printed. This is a 3D printing of a pen stand.
Yep.
Okay, and I have this. Can you see me here?
Yeah, I can. Yep,
Yeah.
yep, yep, yep.
So this is the same photo I took it today only.
Nice.
I
Yeah.
want to show you how this is printed. And I selected this
Amazing.
because there's a story behind this also. I'll tell you why I tell you that.
Okay, okay.
So it starts with a 3D CAD model, which you see on the right.
Yep.
This is the digital input. And how it is done? See, I can design it. I'm a designer. I can make it
Okay.
in a software package called AutoCAD, a 3D system, or a CATIA, so there are so many packages available where you can download. There are so many free softwares also available. I can do it myself, or there are websites where I can go and download the design directly. So I just went to a website and searched for pen stand, and the design is directly available to download. So I
Wow.
downloaded it. So that means somebody has created and kept it for you as a repository.
Yeah.
And many
Yeah.
people
Yeah.
free of charge because they do the designs and then they design it for somebody and then they upload it online. And some people charge for it. Maybe me very small amount, like a half a dollar, $1 up to it can go up to. And if you have a particular design to be made, you can ask a designer to make it, and then he will charge maybe sometime, 100 dirhams, 200 dirhams. There are people who
Yeah.
do
Sure.
yeah, online also. So this is the basics. If you see here, this is the height is around 90 centimeter, width is around 70. It is written over there, and the designs and everything is already there. Yeah. Now I
Amazing.
will show you how it is being done in the
Yeah. Yeah.
software and
Yeah.
how it is actually
Amazing.
being made. Yeah. So now I need a 3D printer, the machine which will make it. Then the machine which I made,
Mhm.
which I used, I have a printer in my office. If you come down to my office one day, I'll show you the printer
Of
also.
course. Of course.
So this is called K1 Max and speedy. Yeah, you see the printing speed is written 600 millimeter per seconds.
Good
And
God.
earlier it was like, it was, I mean, there are 3D printers which are just like a frame and all. Now it is like there is an AI LiDAR, there is an AI camera, there is a 300 by 300 by 300, which is a large build volume. When I say 300 by 300 by 300, it's like I have a plate on which the printing will happen. And the width of this is 300 mm, and the length is 300 mm, and the height is 300 mm.
Gotcha.
So that's what
Gotcha.
the build volume and I can see this happening in my phone when it's happening, and then there is an AI thing. If something goes wrong, it will send a message saying that, though, this is not correct, or it will send a message, okay, adjust this, adjust this. So printing, it has become like a sci-fi movie for me. When I
Amazing.
started 3D printing, nothing was there, but now uh, it has again like a smartphone. How it developed from a
Yeah.
touch
Yeah.
screen,
Yeah. Yeah.
to a smartphone, which is currently, so the 3D printing is advancing like that.
Amazing. Amazing.
Okay, yeah, sure. So let me see. Yeah. So what I do is when I told you I have a slicer. So slicer is also a software, okay, where I import the 3D CAD model into this bed.
Mm.
Into the bed, this is
Okay.
300 mm diameter width and 300 mm length. And so if I see, I can put one, and then I can say, let's say if I want to print 10, I can arrange it across and I can print it across at the
Oh.
same time as well.
Clever.
I can print because
Yeah.
as according to the build volume, I can print. Yeah.
Incredible.
Yeah.
Incredible.
So
Yeah.
there are certain settings which I have to
Huh.
do, but I'm not showing all those things. I just imported it. Yeah. And this is how the print will happen. And then this button, you note, this is called slice plate. So when I press slice
Yep.
plate, what it does is whatever is there in the plate, it will slice. I'll show you
Huh.
that in the next video, next thing.
Good cracking me.
So, okay. So I'm going to
Huh.
play it here. So when I press
Okay.
slice button, there is no sound. So this is
Don't
already
worry.
sliced. So that means it has been already sliced.
Oh, look at
Okay.
that. Oh my
Yeah,
God.
it is made into layer. I'm going to show you here each layer what has happened. Okay, it is already sliced. The sliced information is already there, and I can rotate and see how it is sliced.
Jeez.
Yeah, and this is
This is
how.
amazing.
Yeah, this is how the nozzle goes. You know, each layer that was layer by layer, and this when I go up layer by layer, it shows, and this is inside a layer. What happens?
Huh.
Okay, okay. And if you see, there are
Good God.
377 layers over here.
Good God.
And this is the first, first layer is like zero point 0.2 mm height. Yeah.
Good God. I've no idea.
Yeah.
Incredible. I love it. I
Okay.
love it.
So this is how it is going, each layer, what is happening. And each layer, if you see the height of the thing is around 90 centimeter. And so once I say send to the printer, it will automatically send to the printer. This is how, and then I press a button called start printer. That's how it happens. So
It's like sending something to print from your computer. Yeah?
yeah, I can send it. I can send it. I sometimes I do it from my mobile also. Nowadays. Yeah. And then
Oh
next,
my
I show
God.
you how this is being made. It is a time lapse video of how this happened. Yeah.
Fantastic.
Okay. Let me go to the next slide. Yeah. So this is the printer bed,
Okay.
what
Yeah.
we saw earlier, and
Gotcha.
now you will see the video of how it happened. Uh, it will be showing time lapse, so you'll not see the entire thing moving. But then the nozzle, the what you call it as nozzle, this is where the nozzle is feeding the raw material. You will see only the
Okay.
place, only each layer, ending of each layer you will see. Yeah, just observe. So this is being
Oh,
made.
look. Wow.
It's a 1 hour 45 minutes process, but it is going layer by layer, and it is being made. You know, Tuck, tuck, tuck.
God, look at that.
It's
That's incredible.
yeah, it's incredible. It
Oh,
is.
look, the gaps are coming now. Look at
Yeah,
that.
the gaps are coming. If you see this, the in the video.
Yeah. 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 So it's like one of the slices, one of the
Yeah,
levels, then there's got
yeah,
gaps. I
yeah.
got you. Yeah. Yeah. Yeah.
Correct, correct, correct.
It's so clever.
Yeah, it's pretty clever. Yes.
Yeah. Pretty clever. You think? Yeah. It's great.
Yeah. So in a normal old printer, whatever would have taken around 10 hours of printing, the new printer
Wow.
does in like 2 hours, almost 5 to 10 times
Jeez.
faster.
Whoa.
That's it done. So I'll show you
Amazing.
in a faster way, then you'll understand. See, this the plate is the nozzle is like on the same plane, and the plate, whenever one layer is down, it moves down actually. You see this?
Gotcha.
Each
So
level
it's
is
not the
moving.
nozzle. The nozzle's not moving. The plate's moving. I can see
Yeah, the
that. Yeah.
nozzle is
Yeah.
moving only on the XY plane, which is one layer,
Yeah.
and
Yeah.
the plate is moving down. It is like stacking of layer. So one dimensional printing by the nozzle, and the third dimension is moving down. See like this.
I get it. I get it.
It
Yeah.
it is very clear. It's like something is emerging out of nothing.
That is incredible, isn't it?
So that's it.
Wow.
And why I told this was an important story is once my wife visited my office, and then I told, okay, you're coming to my office for the first time seeing it. I want to give you some gift. So I downloaded it.
Yeah.
By the
Yeah.
time she was there, in 1.5 hours, it got printed, and then so this I
That's amazing. Oh, cool. Look at that. That's so cool.
so it's always in our desk now.
Yeah. Yeah. That's brilliant. Oh, amazing.
So that's that. This is what FDM does, and this is and it is a good tool for creators, makers, creators, hobbyists, and it's not only that. There are so many customer segments where it happens. I'll just show you applications of 3D printing. The most common application of 3D printing is what we call it as service bureau. Service bureaus is a company who will have multiple 3D printers in his office. I have people who have 350 3D printers here running continuously. if you go to that, it is
Crikey.
like a farm, and it is creating parts like that.
Oh,
Yeah, it's called 3D farm. In fact, it is called. There is one guy in Sharjah who was importing um, this ceilings like O-rings. O-rings.
yeah,
Um,
yeah, yeah.
yeah,
Yep.
O-rings. He was importing those from China, and then he found 3D printing is very cheap. And then instead of importing a container of 3D, China, obviously the cost of that material is less, but you have to ship from China to here. Okay, and each one may be costing him 10 fills when it is landed. But in China, but when you have to ship from all the way from China to here, he has to pay the money in advance. He has to wait for 3 to 4 weeks for it to come. He has to store it. Storage is a big cost. Now what he does is he has some 300, 180 3D printers, and he has FDM printers and prints it in situ. So when a customer is there, he gives an order and next day he can deliver, and his money is not stuck. He just need to invest in raw material, and that's what's happening. So
That's
these kind of
genius.
guys are called service bureaus. So they get requirements from the market. They have 3D printers. They buy our raw materials and they do the printing. So that's what is happening for Service Bureau. And Service Bureau is one of the major consumer of my 3D printer, my 3D printing material, and they will print anything. It could be
So
different.
basically, they just so to interrupt, they just need the plan, the 3D image or
Yeah,
plan, and the material, and of
material.
course the printer.
Yes, yes, yes,
Huh.
yes. Yeah, that's what they need. And
Huh.
then they do the kind of 3D printing happening. You'll see UAE. See, though this is supposed to be an industrial use, UAE as a country has been using it where it has nowhere been used. The way nowhere it has been used for awards. In UAE, it's like people like Dubai is a place of events. Yeah. And there is a dinner every night, and then there's an award which is given every night. Maybe thousands of awards given away. And nobody want to see the same award which is coming to them
Yeah.
second, or they want an award which is not seen earlier. And 3D printing is very good because you can customize each design. You know.
So example, and the white badges B&I have given you.
Yeah. Yeah.
You
Yeah.
could do those. You
Yeah,
could
yeah,
do
we
those.
could do
Yeah.
those. We could do those. And if there is a function, there is one 3D company in UAE, Mr. Bijesh was saying, C3D in UAE, in Dubai, all awards are printed by C3D for BNA functions. So it's all customized.
Seriously.
Yeah.
Seriously.
In
And
fact,
can they do writing on it as well? So
yeah,
can you
yeah.
put like B? Oh my
Yes, yes,
God.
the we can. In fact, I should have put a name over here. That would have made it much better. Like just very easy to make engrave a name on top of it.
Yeah, yeah, yeah.
Uh,
Amazing, amazing.
yeah. And then
Cracking. Yeah.
what? In addition to that, what automotive parts? A lot of automotive companies over here are using 3D printing. In fact, there's a company called W Motors in Dubai who makes the guide cars for Dubai police. All
Huh.
their headlamps, the headlamps are a very, very cool design. All are printed in my previous company called Falcon Technologies International. All are printed over here. All the headlamps are
Cracking.
printed over here. We
Unbelievable.
have printed in parts for oil and gas industries from my factory over here. Enclosures have been printed. GE Aerospace uses a lot of 3D printing in their aircraft engines. And when it comes to tooling, the tooling prototypes. I mean, when you see in 3D printing, what happens is we can do customization, but we cannot match the cost of injection molding parts, because injection molding parts you make one tool and make it for 1 million parts, 2 million parts. For example, the cap of this bottle, they will make 1 million
Yeah, yeah.
cap at a cost. So this will cost very minimal. But in the tooling of this cap, there's a lot of 3D printing applications happening. They're like
Gotcha.
3D printing
Gotcha.
and
Gotcha.
used for conformal cooling applications, and there are a lot of things happening in tooling which 3D printing is being used. Healthcare, a big
Ooh,
sector for 3D printing in healthcare, like the cranial helmets which are used for kids with pasiophagy, which is like the when the kids are born, the head of the kid sometimes they're not round in shape, and then they need to correct the head by putting a helmet. And for that, helmets are being 3D printed by a company called Ortho America in USA, and there's another company in Holland which does that. And my previous company used to do insoles. You know, insoles are something which you keep
Yeah, yeah, yeah.
your foot.
Yep,
If you have a flat foot or a condition which
yep,
needs,
yep.
and you cannot make the insole from one mold because every person's foot is different. You know, so
Right.
what we do is you have to scan the foot and make a design accordingly and make it. And previously it was done by hand, which used to take around 1 to 2 weeks. But 3D printing, we can deliver it in 2 days. So we used to get
Sheesh.
scanning of this food done, or what they do is we give a foam plate to the people, and they will press the food inside the foam plate. We will do the scanning of the foam plate, and the data will come to my office, and we have
Oh my
decided
God.
who does it. Next day, the 3D printed food will go there. So we have fitted people while they are about to get into a flight.
That's incredible.
Incredible. I mean, within 8 hours to 2 days, we can do all the things and get it back and done. And obviously, a lot of academia and hobbies. I have some keychains which are 3D printed. Students, my son, a lot of 3D printing of toys happen. I do a lot of 3D printing. You know, so
The other thing that came to mind was a teak at the at RAC, the dental school, because they must have a lot of tools and things they use in dental.
yes, dental, there are
Uh,
lot of applications in dental. And you know, there was this rack tourism development golf
okay. Yeah.
trophy, the trophy which is
Yeah, yeah, yeah.
that is 3D printed. Did you know
And
that?
do you know what? Yeah, I looked at it because I saw it in the golf club,
Yeah,
and I did
it's in the golf
wonder.
club. It's in the golf club.
Yeah,
Yes. Yes, it is
yeah,
3D
yeah, yeah.
printed by Falcon Technologies International. That is designed by the team. When I was there, it was designed by the team member over there, and it is being used. And every year they place
Yeah,
order for the 3, 4 globes. You know, it's 3D printed.
it's
The
just
trophy and the
amazing.
base and everything, but the covering is, you know, it's like as I told, 3D printing is not a solution for everything, but using 3D printing and other technologies together create wonders. You know, yeah.
Amazing, amazing. Yeah, okay.
Yeah. So let's say, okay, this is the global market outlook coming to the numbers. You know, as a
Oof.
BNI, we should speak numbers. So right now,
Whoa.
27.52 to around 30 million, we can say is what is the billion is the total market of 3D printing globally, and is
Okay.
expected to reach 150 billion by 2032. That's a projection, around 25% growth year over year, what is expecting.
Huge.
And out of this market share, FDM or what I use, it's around 10%. And then
Okay.
there is metal 3D printing, there are other technologies, SLA. There are different technologies is what being used. But the most important thing to note is this one, the total manufacturing ecosystem or the world is
Yep.
13.2 trillion. And
Jeez.
27 billion is just 0.2 percentage. You know, that means it is just a small trickle. That means
Yeah,
it
yeah.
has not even started. The thing
I
has
was
not
going to say,
even
just
started.
imagine the future. Yeah,
Yeah. This
imagine.
is so if we are able to capture 1% of the total manufacturing ecosystem, and trust me, it is happening. The time we speak, uh, China has revolutionized things. So I was in last year, I was in a meeting with a guy in China. He was showing me how 3D printers are used. The maximum 3D printing I have seen is like 150 to 200 in Dubai. You know, that's what I've seen. Then he has this massive machines of 600 mm by 600 mm. That's 60 centimeter. Okay,
Yeah, yeah.
one line 100, another line 100. He's
Whoa.
he's showing me in during this video call. Yeah, this is 100. This is 100. I was like, what is this? In my
Yeah.
mind, 3D printing is like distributed manufacturing. Okay, it is used. It is to be used at the place where it is being applied. But China has
Yes.
revolutionized that, saying that no, no. What we are doing is we are doing 3D printing as a farm in China and exporting it to all parts of the world. I mean, they
Good
have made
God.
it that much cost effective. Then I told him,
God.
okay, it's so amazing. I told it's so amazing that you're using 3D, this many 3D printers. He told, no, no, wait. I have to go to the second floor and show you the second another floor. So he's having 2 to 3 floors of this arrangement happening, and he's saying every day, every day or every week, one big container of parts go out from his company to all over the world. And
and
I was
and the
like,
minimal labor, yeah, minimal labor.
minimum labor. Yes, very minimum labor. And then I was like,
Wow.
who is using it? Then I went across Dubai and asked people. There are people who imports one container a month of these parts printed from outside. Where are they using it? 3D printing models, housing, so many things, small things they're being used. I mean, so this chart may accelerate much faster because this are information coming from the western part of the world where data is available. Uh, and the last
Gotcha.
3 years,
Gotcha.
China has overtaken all the Western companies
Mm.
in 3D printing. Be it in metal 3D printing or FDM or anything, it's like electric cars. Electric cars,
Yeah, yeah.
people in UK, in Germany, they used to be very proud that we are the topmost in like car manufacturing. But China has overtaken them in last 3 years. All the electric car manufacturing is happening in China. Same thing is happening in 3D printing. I can tell you. So the
Yeah, yeah.
numbers will be
Amazing.
faster. And the way the Chinese companies are growing, even in earlier, it is like 3D printing was a technology where like, okay, we are like the technology, we will not be able to, other people will not be able to compete. It was about German precision,
Yeah,
those
yeah,
kind of
yeah,
things.
yeah.
But now gone. Even companies in Germany are buying 3D printers from China.
Oh, that's incredible. Bloody hell.
Yeah, it's incredible.
Incredible.
So the
Incredible.
numbers will change in the next 1 year, maybe when the results come from Chinese companies. It's amazing. Yeah.
Incredible. Incredible. What a place to be, eh? What a place to be.
Yeah. Okay. So, coming to benefits of 3D printing, obviously rapid prototyping. When rapid prototyping, I means you have a design and you
Yeah.
always, draw it on paper and then,
Yep.
but
Yep.
unless it is coming to the physical level, you will not be able to, test it in the market. And this 3D printing helps to do that very fast. From design to first prototype, it's earlier, I know people, I used to wait. I had a project in when I was in Wipro in metal 3D printing. There was a new design of an aircraft small jet engine. If they were to
Yeah.
make it using conventional methods, it will take minimum 1 year because the material has to be imported, then it has to
Huh.
be. We did that project in less than 4 weeks. The entire jet
What?
engine was assembled, the small one. It is a working prototype of a jet engine was assembled in less than 4 weeks. We did that in
Jeez.
it was
Wow.
very, 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 very fast prototyping we can do. And it was a working model, not just a model which looks like it. It was a working model of so product to market, you can do it very fast. And then design freedom. See, when you have this anyway, you can design it and you can manufacture it. Almost anyway. There are certain things which is coming to it, but design freedom. The engineers get a design. They can design according to what they want, not like according to what can be manufactured. Earlier, it used to be design to manufacture. Now it's like design according to what you want. So that's what the
Yeah.
freedom that
Amazing.
designers get. And mass customization is something which I told about this insoles.
Yeah. Yeah.
Insoles, we used to print 3,000 insoles in a year, 3,000 to an average of 10 insoles per day, we can say. So that mass customization cannot happen in a conventional method. Only 3D printing can
No.
give you that mass
No.
customization when it comes to, and one of the most mass customization which is happening in the world is like the invisible aligners. If the teeth is not aligned, you put some aligners. Earlier it used to be like the braces.
Yeah.
But now
Yeah. Yeah. Yeah.
there's a thing called invisible aligners. It will just fit in your mouth and then it will automatically, after with a week, 4 to 5 weeks, it will automatically align. And that invisible aligners are made using 3D printing as the base. There's a base product is 3D printing for that. So this mass
Amazing.
customization is possible only in 3D printing. And supply chain issues, I have told there was one guy who is doing this 3D printing over here instead of waiting. And this became very
Amazing.
prominent during COVID-19 times when people were not moving. If you can
Of
manufacture in
course. Yeah. Of
that
course.
was, and there is something called light weighting. So what happens is in conventional methods, if I want to make this, I want to make this. Let's say I'm doing using it through machining. So I have a block of this, and I have to machine it out, carve out. So the more time I spend in carving out, the more cost I'm incurring. Okay, but when I'm using 3D printing, I am depositing material only where it is needed.
Yeah. Yeah.
Lightweighting is a good opportunity. And many places, what happens is the strength of the part is not on the amount of material, but on the amount of material where it is maximum stressed.
Gotcha, gotcha,
So
gotcha.
you have a lot of opportunity lightweighting, especially in space and aerospace applications. Otherwise, it would have been a very costly technology, and in aerospace and space, lightweighting becomes it. I used to in my previous organization, I used to work for a company. I mean, it's called ISRO. For them, for when designing a satellite, when it is to be launched into the orbit, the weight of the satellite and the life is very critical because at the last, the payload which goes into the rocket, the capacity of the rocket is important. And weight of the satellite, let's say it is 1,000 kilograms as a whole, half of it will be fuel.
Yeah,
Because once
yeah.
the satellite life is finished, it has to be thrown out of the orbit. Otherwise, what happens? The space, it will be in the space and it will be orbiting and causing problem. So if they can carry 1 gram extra of fuel, the life of the satellite will be increased by that much amount, and they can carry more components for analysis, etc. So they want to keep as light as, so every gram used to count in space. There was one project, the component was around 1,600 grams, 1.6 kilogram. They wanted to reduce to 800 grams somehow. No way possible
Okay,
other
yeah.
than with additive manufacturing. See, when it comes to a
Huh.
normal component, 800 grams is nothing. But when it comes to the satellite, 800 grams is a very big thing because 800 grams
Yeah, yeah, yeah.
component is 800 grams additional fuel, which means they can stay in orbit for more time,
That's incredible. I'm learning a lot here. This is brilliant. I love this. Thank you.
Yeah, yeah.
Thank you.
And then material wastage reduction, it is, as I told, if I'm making it through conventional methods, I have
Yeah.
to carve out a lot of material, but when it is 3D printing, I just print it,
It
use
wasn't there.
only the
It wasn't
material
there in
which
the
is
first
3D.
place. Yeah.
Yeah, yeah.
Yeah, yeah. I love it. I
These
love
are
it. I
advantages
love
of
it.
3D printing and benefits of 3D printing. I can go on, but
Sure, sure.
disadvantages of 3D printing, I want to touch upon here. As I told you, it's just a manufacturing method. It has to be used where it is applicable a lot. You know, first disadvantage is printing speed cannot compete with mass production. Let's say I printed this in 1.5 hours, which is very good comparing that I have to go to the market, buy the material, come back. But when you're producing in mass, this component will come out in 1 second.
Yeah, 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 yeah.
So 1 second and
Yeah.
1.8 hours is never comparable. So
Yeah.
there is always a speed. 3D printing has not reached, even though I told it has reduced from 10 hours to 1.2 or 1.8 hours. It is not ready to compete with mass production. So if it is the same part I'm producing in 1 million, 3D printing will never be cost effective. So that's one thing which is there. So costs are still high for materials, the machines, the costs are still high. Another disadvantage is not all materials can be 3D printed. You find a lot of materials across, but not all of them can be 3D printed. So there is one
Ah, okay.
limitation. And then when it comes to aircraft and mission critical applications like space, aerospace, there are a lot of prove out and certification requirements which are still unaddressed. Because if I'm doing casting or any other process of manufacturing, we have 300 years of data which is available for each failure modes which has happened earlier. Okay, and the safety factors have been incorporated, but 3D printing is like 40 years old, and we have not seen many applications. So what happened is the failure methods are not fully identified.
Gotcha.
So there is a hesitancy in people to adopt it completely. I say, okay, we can do it, but there is a certification requirement. So there is a lot of certification and standardization is still in the throughout and process. And then size
Okay.
limitation.
Yep.
Obviously, the size is limited by the printer size which I have, which is less than a meter till now. Now there's a company in Dubai who has made a 6 meter boat using 3D printing. I'll send you the link later. So the
Wow.
size is increasing, but not to the size where it can be printing everything and anything.
So hang on a minute. So I sail a laser dinghy, which is kind of 5 meters long. So you could make me a laser dinghy, yeah? Yeah.
Yeah, yeah.
I bet
Now,
you
now
could.
we can make it 5 meter long. There is one company in Dubai who can make it. And then
I'll
another
tell
thing is,
I'll tell Claire.
yeah, and post-processing requirements. So what happens is, let's say I bring out, and there might be some surface finishing requirement which is required because this is layer by layer. Obviously, if you look closer, the layers will be visible. So
Yeah,
if
yeah,
somebody
yeah,
want a
yeah.
very smooth finish like an injection molding, then you need to do something else on top of it. But now I have printed a car part and given to a guy. I told, see, there are lines which are visible. Oh, lines are cool. That was just.
Oh, I like it.
Yeah.
Yeah, yeah.
So the line was an inherent defect of the or inherent limitation of the product, but he found it attractive, you know.
Yeah, 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 yeah. Each to their own. Yeah,
Yeah, yeah.
each to their
So
own.
post-processing requirements is something which might be not on an aesthetic part, but when it comes to a functional part, there could be some post-processing requirement that is needed. Yeah. And then coming to, as I was telling, 3D printing in UAE is still in beginning stage. 2013 is where the first companies started establishing that's like 12 years back. And now there are around 100 companies doing 3D printing, including
Oh,
manufacturing. Yeah.
oh,
Like we are the
wow.
only manufacturer of 3D printing materials in UAE. Others are using our services. And in fact, in the last 3 years, almost 60 of them got registered in the last 3 years. Yeah.
Wow,
Yeah.
wow, wow,
And
wow.
then and the biggest industry which got transformed in UAE is model making. So there is a company
Amazing.
called Artistic, and
Uh-huh.
Dubai is all about real estate. I mean, there is no fact,
Yeah, yeah, yeah.
there is no denying that fact. It's all about construction and related to construction. And model making is one industry which got ultimate benefit from 3D printing because when a project is launched, you need a very nice model which is being to be displayed in a place, and you need this small, small models which has to be sit there.
Yeah,
There is
yeah.
a company called Artistic in Dubai, in Sharjah, which used to still employs more than 100 people in making those models. In addition to that, now they have around 100 3D printers of FDM, and then there are around 10 3D printers in a different technology, due to which their model making time has compressed from months to weeks. Let's say they want
Good
a
God.
model to be made in 3 months, now they will make it in 3 weeks. Because only those final touching will be done by the people, finishing. All the other
Yeah.
components will be coming from the 3D printer. They do the 3D printing, they start the print in the night, come in the morning, use it, assemble it.
Good God.
Yeah, in fact, for NEOM project, the NEOM project, which was
Uh-huh.
I think in Saudi Arabia maybe 3 years back,
Yeah, 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 yeah.
the amount of 3D printing that happened for making the models it's in the terms of millions of dirhams. So it's
Jeez.
model making industry got transformed, and I told you another industry which got and customized awards. I was telling you about customized awards. Everybody wants a different award this time, So 3D printing serves it's the best. So many
Hmm.
awards being made using 3D printing. It's the way 3D printing was. See, that's the beauty of people, entrepreneurs in Dubai. They have used their mind in a way
Yeah,
nobody
yeah,
imagines they will use 3D printing for.
yeah, yeah, yeah. And there's probably more to come. There
Yeah,
must be
more to
more to
come.
come.
And this
Got to be.
industry is, and India is one of the most advanced country in 3D printing per se for industrial application, but this is not there in India. We don't, see this kind of 3D printing happening. It's mostly industrialized and, costlier machines being used in India. And this is so different industry countries use 3D printing in a different way. And here industrial adoption just started picking up. At NOC, they have used their first
Okay,
3D printing part in 2022 or something. They had in the
okay.
last 22, they had published that in Adipec. They have used this. I have already spoken to MSTEL, EGA, Edge. They all have strategies in place to adopt this technology, but due to certification requirements and other requirements, it is still in the initial stages. Recently, there is a company called Immensa, which digitized almost 1,500 parts of ADNOC into digital format. So they made something called a digital inventory. For example, I have this part and the cap of this is broken. I'm saying about an industrial component. So if I go to a company, they will say, no, no, I will not sell you the cap alone. You buy both of this together, which is like
Yeah, 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 yeah.
$10,000. No, the cap itself is
No, you're
costing
right.
500 dirhams, but they will
Yeah,
not sell both of. So now, if they have a digital inventory and if they know the material of the cap, they can only print the cap and use it, and the component can be salvaged. But who stands for the validity, the warranty, the guarantee, and the IP rights and all? So there is a lot of debate happening. So the first step was to convert, because if you want to make the cap, I need a 3D CAD model of the cap.
yeah, yeah. You do.
Without that, there is no
So,
selling.
So
Yeah. So
example,
now,
my laptop, I've just ordered a new laptop because it's broken at the back. The top's broken where I dropped it and the where the power. If I had a 3D inventory of that, I could send it to the 3D printer and
yeah,
be done.
print
Yeah.
and that will be done, you know.
Ah,
So,
very good. Very
so
good.
that's how companies have adopted it. The digital transformation is happening. Maybe in the next 3 4 years, we will see more things to come. Yeah. Okay. And this is
Incredible.
what I think
Incredible.
is future will come as for 3D FDM, which I told, which we discussed already. It will come as a commoditized item, like a
Yep.
normal desktop printer. We never, maybe 30 40 years back, nobody had a desktop printer in their home. You know, they
No,
used to go
no,
to
no.
some office and get it printed. Now everybody keeps a 3D print, desktop printer at home. So
Yep.
like that, 3D printers also will become, available at home. In fact, I have one at home, and then designs will become available digitally. Like I told, no, this design will be available digitally. So all the parts which we use, like a doorknob or something, it will be available in digital format, which you can download, send it to the printer, and get it done.
Ah! Amazing.
I've seen
Amazing.
students. I'll see that in the next 3 4 years, students in primary grades will start using 3D printing. 2 decades
Yeah,
ago, it
yeah,
was
yeah,
available
yeah.
only in the top university labs. Now it is in USA and Europe. Now it is available for 10th grade engineering students in the normal labs in engineering colleges. Now, next level is all primary students will start using, 3D. Like how I still remember I started using computer when I was in fourth grade. So
Yeah, yeah,
fourth
yeah,
grade
yeah, yeah,
people
yeah,
now
yeah.
computer is nothing. So they will start using 3D printers in fourth grade, second grade like that. And 3D printing will become
Absolutely.
very cheap. It will be like very cheap now, standard, and it will be very easy to operate. Now, still there is some nuances of how to operate. You have to load it, and all those things. Nowadays, it will become like you put the thing as a cartridge, and automatically the machine will take and load it and do things are happening like that. It will become very easy to operate, and standardization and certification will become. And size of the 3D printers will start becoming big. More materials will be available. And another research which is happening now is bioprinting. You'll not believe they will print
Yeah.
organs in one
I've
decade.
heard this. I was going to add, that's one of my questions was as about this because I heard about this some time ago about, literally printing organs.
Organs, yeah. There are a lot of research happening. Even I'm not very much into bioprinting, but there are researches happening in organs getting 3D printed. So meat 3D printing is happening. So this will become very common in the next 1 decade or so. So this is how. I mean, this brings to the end of the presentation. If you have any questions, I'm okay to answer your any queries.
Manoj, I have to say that was one of the most interesting presentations I've seen for donkey's years, for ages, because my mind is racing. I'm looking around the kitchen here because I'm downstairs. I'm looking into the kitchen, going, "We could 3D print that. We could 3D print that. We could," and I see the printer, and
Hello, I lost you, Mike. I lost you.
how it
For
can commoditize it. Because now when you get a manufacturer wants to make the money out of the consumables, very smart, and that's I can see that. Just a question you mentioned earlier that not all materials can be used in 3D printing. Are there any particular materials that cannot be
Uh,
used? You did say
I,
there was some.
yes, in polymers also, there are certain polymers which does not, the 3D printing to happen, it has to first start melting, and then it has to adhere to each other, and then it has to stay as in place. So what happens is there are certain materials which is like when it comes to plastic, there is something called a glass transition temperature, which what says it starts softening and then it starts melting and then it's gradually solidifies. Certain materials
Gotcha.
don't react to temperature till and then at a certain point it starts melting. The window of melting is very small. Then 3D
Gotcha.
printing
Yeah,
of
I understand.
material will not be good. And then
That
certain
makes a lot of
materials,
sense.
yeah, certain materials, when there is a temperature gradient, there is a stress happening because if you see this one, when it starts printing, the layer is at 160 degrees Celsius, which is maybe printing temperature 200 degrees Celsius, and when it completes down, the bottom layer starts cooling, and the top layer is still at 160. And due to this temperature difference, there will be warpage happening. Temperature difference. Certain materials are
Ah,
very prone to warping. Then it will not stay in shape. It will just
very good.
it will
Very
just
interesting.
it will just twist. So there are certain limitations of material. So hopefully, think. And now there are what they do is now people build enclosed machines which are always staying at high temperatures to avoid this temperature gradient. And then they don't
Yeah,
work.
yeah.
But then the temperature, when to keep that material environment at higher temperature, that heat input is high, so it becomes physically non-cost effective to keep that at high temperature. So those are the things which are a lot of research is happening on
No,
why.
amazing,
Yeah,
amazing. I think the other thing that came to mind when I was going, oh man, because it's so interesting, is each week we have two people at BNI that do their feature presentation.
yeah,
So and you can't do that until you finish the MSP, the Member Success Program. So get it done, then we can
yeah,
get you
yeah.
one of the first ones
Yes,
because people will find this interesting.
yeah, sure.
So thank you so much,
Yeah,
Manoj. I mean, that's absolutely been a delight. Um, it's a shame that more people didn't come, but I think we can do something about that.
yeah,
I think this is definitely valuable.
yeah,
I will definitely be shouting about it. And in terms of if you can send me something I can put on a post, so maybe it's that the title slide in a
yeah,
photo in a JPEG, that
yeah,
I can share it and just sing your praises,
yeah,
because people need to know this,
yeah, yeah.
and people need to know this in our network because of the referral opportunities.
Yes,
Because I'm going all the time, I'm thinking, how can I refer them? Well, there must be loads of people. If I start to understand you
yeah,
more and more and more over the weeks of BNI,
yeah,
that I'm going to be able to easily refer you.
yeah.
And on that note, of course, I don't want to make this about BNI, but you really do need to work on your power team
Mm-hmm.
of the people that you want around you really closely,
Yeah.
that you can refer very easily and they
Yes.
can refer you very
Yes.
easily.
Yes.
So,
Yes.
and
Absolutely.
you only get that by doing this education. So thank you
Yeah.
so much.
Absolutely. Absolutely.
Absolutely top notch. Top
Yeah.
notch.
Thank
You know your stuff. You know your stuff.
you.
And you I think you enjoy it a bit too much, a bit like I do. I enjoy what I do. So that's been fantastic. So yeah, but let's have a chat more another time about how we can promote this as well. I think this is a great webinar anyway. You could chop it up, you can edit it,
Yeah.
you can put some things on social media. But
Yeah.
yeah, and the other thing, you do this live. Do this not live here, but up at Compass.
Yeah. Yeah.
They're always looking for speakers. Always
Yeah.
looking for speakers.
Yes. Yes. Absolutely. I'll be happy to do that presentation in Compass.
So thank you so much.
Sure.
Thank
Thank
you.
you. Thank you. My
I don't
pleasure.
have any other questions for you right now, but that's been a fascinating, however long we've been spent together. It's been lovely. So thank you for putting the time in. And yeah, I will. I'm educated. I feel empowered. I feel empowered. Now I'm going to have an hour on BNI training.
Yeah.
So over to
Yeah.
that.
Sure. Happy Sunday. Happy learning.
Yeah, same to you. Happy Sunday and have a good start of the week. I'll see you on Wednesday.
Yeah. Wednesday. Yeah. Sure. Thank you.
Okay. God bless. Thanks, Manoj. Thank you. Take care. Brilliant.